Thank you very much. Good morning. Let's get this show on the road and talk about Spring Framework 6. Oh, and ask questions through the app. Just a disclaimer, basically, if we don't implement something like I said we're going to, you can't hold us accountable, but we're doing our best. So my name is Sam Brannen. I'm American, as you probably tell by my accent. I live in Europe, though I live in Switzerland, been here for over 20 years. I'm a staff software engineer at VMware, and I've been developing Java for 25 years, which is maybe older than some people have been on the planet here. I'm a core committer for the Spring Framework. Started back in 2007 when I took over all of the testing work, and I've been active since then, partially as an external contributor, but again now in the last couple of years as a core contributor working for VMware. And I've been a core committer for JUnit 5, my node JUnit Jupyter program model since 2015. So today we're here to talk about Spring Framework 6, which is the next generation, right, of Spring. We're going to talk about the baseline upgrades, a little bit about declarative HTTP clients, and then we'll talk a bit more about Spring AOT, GraalVM native images, and then we'll look towards the future of what's coming in Spring Framework 6.1 with topics like Project Leyden on the horizon, virtual threads coming in JDK 21, and JVM checkpoint restore. So first up, some of the bigger themes, changes to the Java baseline and Jakarta. So for the baseline, Java 8 was the baseline for Spring 5. Now we jumped up to JDK 17, which is an LTS release. So with the language, we get lots of new features, text blocks, switch expressions, instance of pattern matching, and we actually use all of these within Spring as well, and we're happy to be able to use those and happy that you're able to use them as well. For the core libraries, you have new stuff like collection factories. You can now use records and sealed classes. So basically, we're confident this is a really good baseline for any modern day Java application and any modern Spring application. Next up on the horizon, you probably know later this year, right? JDK 21 is going to come out, be the next LTS release, and we're going to get more language features with that. So pattern matching for switch, record patterns, sequence collections, things like that. That of course we're going to get support for virtual threads, in addition some performance enhancements with the garbage collection. So all of this is already fully supported in our snapshots for Spring Framework 6.1, and you can go ahead and try that stuff out. Has anyone tried out JDK 21? Out of curiosity, a few people? All right. Who's on Java 8? Let's see that. No? Who's on Java 17? Most people. All right, that sounds good. Who's actually already using Spring Framework 6? A few people? Okay. So Spring Boot 3, all right. So Jakarta, yeah, that's kind of a big topic as well. Basically means you have to change a lot of or run some scripts and change your packages. So the baseline is Jakarta EE 9, and if you read the last note here, it says basically it's the same APIs we had before with Java EE 8, but we have a new namespace. So everything that was Java X before is now Jakarta. So for Servlet API 5, you're going to have Jakarta Servlet. JPA 3.0, you're going to have Jakarta Persistence. Being Validation 3, you're going to have Jakarta Validation. And you have to keep in mind some of the things that changed as well, like the add inject annotations, post construct, pre-destroy, these other kind of annotations. They're also now in the Jakarta namespace. However, for a few of the things, we do actually support Java X and Jakarta side by side. For example, with the post construct annotations, we do that. But for core things like Servlet, JPA, Beam Validation, you have to make the jump to Jakarta. Now that was the baseline. We actually recommend that you go with Jakarta EE 10 if you're starting off now with Spring 6 and the upcoming Spring 6.1. Basically that means Servlet API 6.0, so Tomcat 10.1 or Jetty 12. But one thing to note about that, so we build the framework based on Servlet 6.0, so everything's based on that, but we still have Servlet 5 compatibility at runtime. So if you have some existing code that's deploying to a Servlet 5 container, that should still work. But then another thing to note is in the tests, if you're using mock MVC or any of the mock requests, servlet requests and stuff like that, those are based on Servlet 6.0. So you will have to have that in your class path to compile the test and run the test, even if you deploy to a Servlet 5 container. Next up, JPA 3.1. You can use that with Hibernate ORM 6.2. And for Beam validation, you can use Hibernate Validator 8.0. So this is actually the default API level for Jakarta EE in a Spring Boot 3 application. On the horizon, however, Jakarta EE 11 is coming up, and somewhat maybe surprisingly, they hope to have the official minimum requirement of JDK 21 So that'll may force people to actually use JDK 21, even though Spring 6 is based on JDK 17. But some nice benefits for that, right? So for Servlet API 6.1, that would mean they can embrace virtual threads there. And then you could also expect that Tomcat 11 would also require JDK 21 at runtime as well. Then for Spring, of course, Spring Boot, there might be an optional upgrade for Tomcat 11. We'll have to see how that plays out. A few odds and ends regarding to class path scanning. So in 6.0, we did have two major changes kind of behind the scenes you might not notice. But if you've been using module path scanning before, if you're using Maven Surefire with tests and having patched modules, it wasn't always possible to find everything with class path scanning. And we've added in module path scanning support alongside our traditional class path scanning support if you're using the class path star refix, :refix. And for file systems, now we also have custom support for scanning a custom file system. Where that might come into play is if you're using AOT and GraalVM native image. If you have some resources in the image and that needs to be scanned, we can also now scan out of the box the native image file system from GraalVM. So any kind of resources that have been stored in the native image itself that aren't in the underlying operating system file system. Declarative HTTP clients. Has anyone ever heard of or used Feign or OpenFeign? A few people out there, so all right. So basically the idea is that what you want to have is you don't want to have to write all the code yourself, set up the REST template or set up the web client and make all the calls yourself. You want to just have a declarative way and say, I have an interface, these are the methods I want to call, and please, Spring, when I invoke this method, make the call for me on some remote server and take care of all of the marshalling and unmarshalling and all that kind of stuff. So this is analogous to existing projects out there, Feign and OpenFeign, but without the related issues such as lack of non-blocking support or dependency on third parties and difficulty to upgrade and all that kind of stuff. So basically, right now we have the infrastructure and annotations living in core Spring and in Spring Web so that you can use it in your Spring applications, and that so other parts of the portfolio, Spring portfolio, can also build on that as well. The annotations, here we see a list of, basically the core is HTTP Exchange, because it's basically like a web client exchange, as you want to think about it, like you're contacting the other server, but you're writing the actual client. And then we have specializations of that. So we have post exchange, get exchange, delete exchange, etc. And these are analogous to what we have in Spring MVC, right? So we have request mapping and post mapping, but we don't use those because those are specific to the server, and these new annotations are specific to writing a client API. In terms of the arguments they can accept, you could also use a lot of the annotations we already have for Spring MVC that you might be familiar with, things like request header, path variable, request body, cookie value, and things like that. So there's some similarity, but it's focused on writing the client API to an external HTTP service. And then in the end, pulling that all together, there's an HTTP service proxy factory that's going to actually create the proxies for you, implements your interface, and make all the connections for you. And we'll see an example of how that works. So here we have an interface, straightforward, right? Not extending anything else. Public interface verification service. It defines the method verify. When we invoke this verify method and pass it a customer application, we want Spring to automatically convert that into maybe JSON or XML, send that as a post request to verify on the server we've configured, and then when the response comes back, we want that to be converted, the response body to convert it back into a customer verification result, and then hand that back to us. In this example, we see that it's a blocking call. We could convert that to a reactive call by using Mono here from Project Reactor. In addition, if we need to interact with the response status, headers, and body, and things like that, we could wrap that in a response entity. Now, putting it all together, here we see at the bottom, we have a bean, HTTP Service Proxy Factory. We're using the web client, creating it based on some base URL we've configured for our remote service. We're going to use the web client adapter and pass that into the HTTP Service Proxy Factory and return that. And then anytime we want an actual bean, one of these clients, we can use that factory to create the client, passing the interface, and it will then process all the annotations and everything there and create the proxy for us and all of the underlying infrastructure behind that. And you could, of course, just return this as a bean, right? This verification service, that could be another @bean method. So that's about it. A bit of magic, but it really simplifies your code and keeps you from having to write all of the web client adaptation code yourself. So ahead of time, who has ever used GraalVM native image deployments? A few people? Who's ever heard of ahead of time, Spring AOT? A few people? All right, so we'll dive in a bit more. So when we talk about ahead of time, what we mean is anything you do before runtime. So basically during the build, some kind of processing we can do. With Spring, what we do is we analyze your application. So we get it up to a point right before we create all the beans. So we have all of the metadata for all of the beans in your application, the configuration, profiles and stuff like that. And then we're going to basically generate code on the scene, behind the scenes on the fly. So we use Java Poet for that. And we basically take all of your annotation-based configuration or XML-based configuration, if you still have that, and we put it, we convert it into like basically a functional version of that, and you can actually view the code. We generate that code during the build process and then compile that, and then later on, when you start up running in AOT mode, either on the JVM or in a native image, instead of going through all of your configuration classes and finding your bean methods, it just invokes this functional code that creates your beans for you. That's the basis behind it. So in Spring, the goal really is to reduce startup time and memory footprint in production. And for native support, in addition to creating all of that code for your beans and the metadata and all that, we also generate runtime hints. That's necessary for a GraalVM native image in order to be able to use things like reflection, resources like class path resources, serialization to generate proxies and stuff like that. We generate that. If we don't generate it for you, we have ways for you to generate that yourself, and you can check out the documentation on that. In general, you could do this, as I mentioned, for optimized JVM deployment using Spring AOT for a little faster startup, but it's a precondition for running within a GraalVM native executable. So all the core infrastructure is baked into Spring Framework 6, and it's depended on by the rest of the portfolio. And then in Spring Boot 3, you have the build tools in there as well that know how to run the AOT processing during your build phase, and also how to build the native images for GraalVM. In addition, last but not least, you can, of course, test. That's something I focus on as a JUnit committer and core Spring testing committer. So you can test within a native image. We have a nice collaboration with the Micronaut team and the Oracle Labs team and the Spring team building on native build tools. That's an open source set of tools for Maven and Gradle. And we use that, and then also we have support in there for running all your tests in a native image. So what it'll do, you have your JUnit tests, like JUnit 4 or JUnit Jupyter, and it's going to actually run them once, figure out everything you wanted to run on the JVM. Then it's going to compile a native image with all of your tests in there and with JUnit platform in there, and then it's going to run all your tests inside the native image. So that gives you at least a good feeling about whether or not your code is going to work when you deploy it. So it's really nice to be able to do that. But a note on that, the build for native image can take quite a long time. The same for the tests. Once you actually have compiled into native image, the tests run fast, but it takes a while to build those images. So you see this note here at the bottom that AOT is a trade-off. It's an extra build step, and you have less flexibility at runtime. So again, everything's going to be pre-computed based on when you built your application, and a bit less dynamic than a normal Spring application would be. GraalVM native image, that's the de facto standard in the Java community right now for creating a native executable, so targeted for a particular architecture. It has a very strong, what we call a closed world assumption. That means that once it's built, it's built. You can't dynamically load classes. You can't dynamically compile things and stuff like that. You don't have any kind of runtime adaptations. It's really an executable like anything else. Like someone uses an executable, this one runs on Windows, this runs on Linux, this runs on Mac OS, things like that. So the AOT stuff, that's all processed, that serves as input into the native executable. And again, you will have very long build times compared to what you're used to. So normally if your build might take like 20 seconds in Java, it might take 3 minutes, 5 minutes, 10 minutes to build a native image, depending on how complex it is, how many dependencies you have, et cetera. So that's one thing to keep in mind. Typically with the native image stuff, you might do it sometimes, build it sometimes locally on your machine, but you're probably going to have that in a CI pipeline so that you're not waiting on that and dealing with that on a constant basis. And it's definitely not something that you're going to have in your daily workflow. You're not going to be building a native image and testing it repeatedly, right? You're still going to write your code in JVM, Java, run your tests in the JVM in your IDE, local build in the JVM, and then every now and then build for native and test in native. So it's a very different mode of deployment, but it also has very strong benefits as well as some limitations. So with native image, you're going to have smaller footprints, super fast startup time. It's really great for cloud deployments and things like that. Project Leyden, who's heard of that? Anyone? No? Okay, interesting. So here's a link to the project page. Basically, this is a movement that's been pushed within the OpenJDK to introduce what they want to call well-defined static images, and it's inspired by the popularity of GraalVM in recent years, but they want to take a more gradual approach. So what they want to do is they want to start off with some weaker constraints, limiting what can be done, like maybe limiting the reflection, maybe limiting dynamic class loading, things like that, and then they want to have more runtime flexibility to start, and then in the end, they want to basically see if they can get as far as something like GraalVM native images. But it's going to be a gradual process over many years, allowing you to have some of the benefits of a native image style static image deployment within the JVM itself, within a normal JVM deployment. And for Spring, that works out nicely for us because our AOT strategy aligns nicely with Leyden's JVM strategy. So as I mentioned, you can use Spring OT in a native image, but you can also use it in the JVM, and this will probably work out nicely with Leyden. And we'll keep up with Leyden, see where they're going, see if we have to make any changes in Spring in order to make the best of that as well. Virtual threads. Has anyone played with virtual threads? Yeah? Anyone else interested or thinking about it? Okay, a lot of people. Is anyone using reactive programming currently? Spring Webflux or anything like that? A few people. Okay. So, Project Loom, right? Virtual threads were previewed in JDK 19. The goal is to have a lightweight threading model within the JVM itself, designed as a virtual variant of the existing Java Lang thread, so they won't have to change too much of our code. And the main goal is really to give us better scalability in an imperative programming model instead of having to switch to a reactive programming model. So basically, you don't want to be blocking any operating system threads when we're doing I/O operations. Now, JDK 21, again, that's coming out later this year. That brings virtual threads out of preview, so it's going to be a core feature in the JVM, even part of an LTS release, so that's good news for all of us. There's a new builder API on Java Lang thread in order to get a virtual thread, and there's also some new executor service variants as well. Basically, this should give us, ideally, seamless interoperability with our existing code, and we'll basically avoid synchronization around any I/O operations. Now, in terms of Spring, we've had the simple async task executor for a long time. Now it has a new flag. You can say set virtual threads true, and that will switch it to using virtual threads behind the scenes. So if you already have that configured and in use, you can just turn on virtual threads very easy like that. However, we do have a new variant of task executor that's specific to virtual threads, and you can use that one if you want as well. So one of the nice things about Spring, a lot of places you just have to specify a task executor, and it's your choice which kind you configure. So in the past or currently you might be using the simple async one, but now you can just switch to a virtual one basically in your configuration without changing any of your other code, and the virtual threads will just be used transparently behind the scenes. And you can configure things differently, right? You can configure a task executor for messaging, one for scheduling. You can decide which ones use virtual threads, which ones don't, etc. In terms of Spring MVC applications, so for Tomcat and Jetty, you have to set up the executor for virtual threads. There's some blogs out there on how to do that, and those projects will be making it easier as they move on to or integrate official support for virtual threads. But in the interim, we have a blog on a post on the Spring blog about how to do that for Tomcat if you're interested in seeing how to do that with the Spring application, Spring Boot application. Now for database drivers, you're gonna have to make sure you get the latest and greatest that support virtual threads. And in Spring Boot 3.2, there should hopefully be some first-class support for turning on virtual threads where Spring Boot can take care of it in the places that you need it. But that's still on the horizon for the next couple of months this year. So ideally, right, we shouldn't have to make any changes in our actual code base, right? So we just change how our server's set up, how Spring's set up for scheduling and things like that, and we can basically switch from standard threads to virtual threads. In terms of Spring Web Flux, that's the reactive support in web in Spring. Basically, you have scalability through a reactive programming model with stream-based access with back pressure enabled drivers. So this is going to be very efficient in general, right, if you want non-blocking support. But you can also potentially have some blocking user tasks that are running on virtual threads. So you can actually combine reactive programming with some tasks that run on virtual threads at the same time. For MVC and reactive programming, that's actually been there for a while. Some people have not realized that. So Spring MVC actually understands reactive return types in addition to the standard return types. So for example, you could have a reactive data store access only for specific web endpoints, and Spring will look at the presence of reactor on the class path to see if it's there and see if it can handle any reactive web endpoints based on the return types, getting like a mono or flux back. So basically that means that this is a nice combination, right, with the virtual thread power and the reactive options at the same time within Spring MVC. So you have the option to use reactive types in Spring Web Flux and also have support for virtual threads. And in Spring MVC, you can have the standard Spring MVC model with reactive programming or combine that with virtual thread support as well. So in general, the benefits, we hope, right, we get higher scalability for our existing applications just by turning on these switches. However, it might not be the case, it ends up better, but maybe we get the same scalability, but smaller footprint, so that's still a benefit for that. And then we're of course going to have benefits for our JDBC, JPA database interactions. And also, anyone still use a REST template? Few people? Anyone use web client? Not so much? All right. So REST template has been around for many years, right? And web client is the reactive kind of brother or sister to that, sibling. And when we talk about virtual threads, it's also a good fit for HTTP interactions with the REST template if you're still using that. So you can basically switch to virtual threads and get some higher throughput for REST template usage for your clients. So we recommend and I hope and encourage that you'll check it out, take it for a spin. 6.1 milestones for Spring, and then try that with your web apps. Let us know if you switch to virtual threads, if you're seeing improvements, or if you run into any issues, please let us know and report them, and we will see how we can address those. JVM checkpoint restore. Who has heard of Project CRaC? Anyone? A few people? Okay. So this is a new development in the community in recent years. Some research on that. Basically, there's this new project called Project CRaC. CRaC stands for Coordinated Restore at a Checkpoint. So it's basically, you take like a snapshot of your application on the JVM, you save that out to an image, and then later on you can start it up right where it left off. So basically the idea is, bootstrapping from a warmed up hotspot JVM image. This thing was originally developed by Azul for OpenJDK on Linux, and then adopted by Amazon. You might have heard of Amazon AWS Lambda Snapshot, similar approach there, and that's something we're also looking into for 6.1. Now the requirements, what happens is at this checkpoint, one point, you have to basically pause the application. You have to make sure you don't have any open network connections, no open file handles. You have to make sure your spring beans are stopped, basically not trying to process something. And then at restore time, you want to reestablish all those connections, those listeners, restart those beans, etc. Now in Spring, we actually already have support in the milestones for Spring Framework 6.1 M1. You can already check it out. We also have some documentation online. You can read up more on that, how to configure it, when to start or when to take the checkpoint. So basically, there's going to support for a custom checkpoint after the application has started up. So after your Spring application has started, after the application context has started, all the beans are running, you can say take a snapshot right then. And then the application context will get these checkpoint restore notifications. And then it will propagate those, either the stop signal or the restart signal, to all of the participating beans. It turns out it works out very nicely in Spring. We've had this lifecycle interface for many years. So if you have any beans of your own that implement lifecycle, they will be told to stop at the right point and told to start at the same point. But that also holds true for lots of the beans in Spring itself, like the message listener containers and things like that that already participate in the lifecycle management. Yes, for example, the first one here. So what happens when lifecycle.stop is invoked? You should stop all of your asynchronous processing. Make sure you close your connections, close any file handles and things like that. But you want to keep your state intact in terms of like the state of your components, like any kind of fields they have and things like that, because they're really just going to get paused, and then there's going to be a snapshot, and they're going to be stored to an image, and they're going to be brought back to life, so to speak. So when we talk about this, stop is not equal to the destroy call, because the destroy call means get rid of it and clean up everything as if the object is going to go away and the application is going to stop completely. All right, this is different. We're just going to pause in the middle. Then you need to be able to restart once lifecycle start is invoked. And then the other point is when you do have a destroy call that follows the stop call, then you should actually shut down completely. So some common Spring apps working out of the box. Standard lifecycle coordination through the framework itself. Embedded Tomcat and Jetty in a Spring Boot application. Those can participate in the stop and restart callbacks from the CRaC support there. And Spring Boot 3.2 will hopefully be able to support some common checkpoint choices. So, for example, one could be right after startup of the application, before any requests come in or something like that. Another idea would be to have custom checkpoints where you say after some timeout, some period of time, maybe after 5 minutes, take a snapshot then, or maybe there'll be some way, I'm just thinking out of the box, they might have some kind of management endpoint where you could say take the snapshot now. So after a certain point, you could decide that for yourself. The image will be stored, you tell it where it's going to be stored, and then you could restart it later. So ideally, similar to with virtual threads, we hopefully shouldn't have to make any changes to our own application code base unless you have something that's dealing with resources, handling files and connections, stuff like that. You either might need to start implementing lifecycle to make sure you're getting the stop and restart callbacks, or if you already implement lifecycle, you might need to make sure that you're not actually losing state between the snapshot and when it gets restored. So for the roadmap, Spring Framework 6.1, we're already working on that. Spring Boot 3.2, already working on that as well. So Spring Framework 6.1, we already had the first milestone 1 released a few weeks ago. We're working on M2 now and hoping to release that in mid-July. Spring Boot 3.2 should also come out in mid-July. And then later on this year, we'll have the release candidates in October, and hopefully the GA releases should be out in November. So please give our milestones a try and let us know what you think. So I have some time for questions, and I also could show a demo, a small demo of AOT and native image. I kind of leave it up to people in the crowd. Should I show a small demo? Yes, okay. All right. So I did this one for Spring I/O. I'm sorry it doesn't say go-to. You just have to assume it says go-to. So this is a very simple application, simple boot application. Really nothing special here. Just made it from start.spring.io. I have a service in there that has an implementation that was more for testing purposes. Basically, it's just going to say hello Spring.io. And on the website, we have a controller. So just a standard Spring MVC controller that's going to return the message from the service when we have a GET request to /hello. So if I go to, if I run it, who wants to wait a minute to see it compile? I could just show you how fast it runs. Do you want to wait a minute to see it compile? This application takes a minute. I have spared you the pain. So if I run the Maven command to generate the native image and compile it, we'll see that it took actually a minute, which seems quite a long time, right? For a standard application, or this simple, it has one service and one controller. And that's because it's creating the entire native image. And if we go look at that, it's this one here, and it's 67.9 megabytes. So the whole thing is in there, right? All of Spring, all of your application, all of Java, that's one standard or one executable that's been built for my MacBook Pro. It only runs on architecture that's compatible with my MacBook Pro. So if I wanted to actually run that, I could run that Spring I/O. It started up in 46 milliseconds. So that's pretty fast startup time, right? And otherwise, it looks like a normal Spring Boot application that's running. And just to prove that it works, hopefully if I hit return, yes, it runs. And if I put in something else, not that I'm faking it, hellos, yeah, it's not running. So that page isn't there. Just a hello page is there. But you see that it works in that sense. The tests as well. So if I were to run the test, let me go ahead and kill that out. When I ran the tests from the Maven build, it also took about a minute. We see that it ran all of the 3 tests that were in there and took a minute. But that's then compiled into a native image. We see that's here as well, native tests. And that's a little bit larger than the normal one because it has JUnit and some other stuff in there. So that's about 75 megabytes. And if you wanted to see those tests run, it's the native tests. That also ran very fast. I guess I could time it, right? Well, 48 milliseconds for the actual tests in JUnit, but for the whole process, yeah, like 86 milliseconds. So that's actually starting up the native image. JUnit's running. It's running all of our tests. It runs your entire test suite for your current project. So we see there, those are the benefits. Normally, you're going to not build it for your MacBook. You're probably going to deploy it to something like Linux. So you're going to need some kind of container. There are many tools out there for build packs, Paketo, and other things like that that allow you to, on your computer or in your CI, to build for a particular target architecture for Linux for what you're going to deploy into in the cloud, things like that. So, but otherwise, that application looks just like a normal application. The tests are in there. Like I said before, you would normally just run the tests in your IDE. They should work as well. And this is the exact same test that ran within the native image. And this code here is the same. One thing that's different is this stuff is all generated. So I do have generated code in here. I imported that. So you see here target Spring AOT. This is a Maven build. These are the test sources. I could also look at the main sources as well. But in general, you see there's a lot of stuff that's generated in here. You see stuff for boot, stuff for Spring test context, so the generated classes that were there, all these initializers, we could probably go look at one, and we could see that it has its own bean factory registration, and it's registering the beans. This is what I was talking about. This is all the code that we had in annotations or maybe in XML or some other custom metadata format. This all gets converted into straight up functional code. So all the code is in here, register bean from the bean factory, this instance, and you have all of the beans in there. For the actual application, this was my, for the Spring I/O application, the Spring Boot, it has this set instance supplier here, the root bean definition, and that's how it's creating all these things. And if you wanted to look at the, let's see, oops, target Spring AOT, just the test because I cleared it out. I don't know if we want to go back and build the other stuff. But basically for the production code, it does that as well. So it's going to go through all of your configuration classes, well, through all of the beans that are registered in the bean factory and generate code for that. And this is all generated with Java Poet, even with documentation. We're nerds, but we thought people might look at it and read it, so we have documentation in the generated code as well.